Alright, reversing a linked list. This is one of those classic problems that trips people up because pointers get confusing fast. But here's the core insight with the recursive approach. We dive all the way to the end of the list first, and then on the way back up the call stack, we flip each connection one by one. It's like unwinding a chain from the last link backwards. Once you visualize that, it all makes sense. Super simple setup here. Our list node class just holds a value and a pointer to the next node. That's it. Every node knows its own value and who comes after it. Think of it like a conga line where each person only knows who they're holding onto in front of them. Here's our base case, and it handles two scenarios. If the list is empty, or if we've reached the very last node, we just return that node. Why? Because the last node in the original list becomes the head of our reversed list. This is the anchor point. Recursion needs to know when to stop diving deeper. This is where the magic starts. We recursively call reverse_list on head.next, which basically says, hey, go reverse everything after me first, then come back and deal with me. This call keeps diving deeper and deeper until it hits that last node. And whatever comes back? That's our new head of the fully reversed list. We just hold on to it. And this is the key insight that makes the whole thing work. Head.next equals head. Read that carefully. We're saying the node after me should now point back to me. We're literally flipping the arrow between two adjacent nodes. If node A points to node B, after this line, node B points back to node A. That's the reversal happening one link at a time. Now we set head next to none. Why? Because we just reversed the connection, but the old forward pointer is still there too. If we don't break it, we'd have a cycle, two nodes pointing at each other forever. Setting it to none cleans that up. For the very first node in the original list, this none becomes the tail of our reversed list. Perfect. Finally, we return new_head. Here's the beautiful thing. This is always the same node being passed all the way back up through every recursive call. It's that last node we found at the base case. Every level of recursion does its pointer flip, but they all faithfully pass along the same new head. That's how the caller gets back the correct starting point of the reversed list. Time complexity is O of n. We visit every single node exactly once. Space complexity is also O of n because of the recursive call stack, one frame per node. Here's your memorable takeaway. Recursive reversal is all about trusting the recursion to handle everything after you, then just flipping your one connection on the way back up. Divide, conquer, flip. Beautiful.